Okay, this is another short video on the creation of the bracket part for the flat pulley assembly. So I've created a new file, I've called it bracket, saved it into the same folder as the previous parts, and I've copy pasted in a snip of the dimensions for this part. So I'm going to just have a quick look at the design intent of this first of all. So the overall bracket is going to be symmetrical, about a vertical plane here, I suppose. The important dimensions will be the height of this hole from it must be measured from the very bottom of the bracket, and the two holes here have to be made so that they can mount properly onto the base part which we previously made. So the important dimensions there are the center to center, that the holes are dimensioned center to center and 20 millimeters from the back surface of the bracket, so that it'll mate properly with the base part. Okay, so I'm going to do most of the work in this elevation here, but the way that this bracket lines up in the assembly means that I'm going to sketch that elevation on the right plane, so that when I go to assemble this all together it will line up nicely for me. Okay, so I'm going to create a sketch on the right plane and create a new sketch, and I'm going to roughly draw out this view of it here. I'm going to set it up so that the origin will be here, but I suppose you could equally make it so that the origin is down at the bottom. And actually, in fact, yeah, I think I will set the origin down here so that it will line up when I go to assemble it all together. So I will do it that way instead. So I'm going to draw a rectangle, and then somewhere above that rectangle I'm going to draw a circle and another circle. Okay, now in order for this thing to be symmetrical, what I want is the hole in the center to be above the midpoint of this line down here. So I can either hover until I find the midpoint, or I can right click and go select midpoint, then control click on the center of this circle up here and put in a vertical relation. Okay, so that circle now is above the midpoint of the rectangle, so it's essentially makes the part symmetrical. Now I want to create a line, so right mouse button and left, and I'm going to create a line from the corner here, and I want it to be a tangent to this circle. So just move around slowly until you see the tangent relation symbol appear. Now you could manually put that in as well, but yeah, no, I'll just get it to automatically do it here. But just to demo it, maybe I'll put the line I'll just draw a line, I suppose, just to show you that you don't have to rely on the automatic relations. So I could take the point at the end of this line, control click on my circle here and make them coincident, and take this line and the circle and add a tangent relation as well. So that line now will always stay tangent to the circle. So you can see that the point where it touches off the circle changes as the geometry changes, but it always stays tangent to the circle there. So that is the general shape of the part. I need to add in some more dimensions now to fully define it. So what we want is a dimension from the bottom of the part to the center of the hole of 55. We want the height of this part here to be 8. we want the circle, the inner circle, to be diameter 12 and the width of the base here to be 60. Now if I put a dimension on this circle at the moment, I'll just do it to start off with. What I want when I finish up is I want to have a radius of 15 on that arc, but to do that I'll have to put it in as a diameter 30 to start off with. And if you dimension it while it's a circle, you'll wind up with a diameter dimension. I'm going to use the trim tool now to just trim away the bottom part of this circle here. So you can use the trim tool in a number of different ways. You can use it in a similar way to what you may be familiar with from AutoCAD. You can use it to trim away between lines. So I could use that to trim the circle between these two lines, or you could use it to trim outside lines and that kind of thing. But in a lot of cases the power trim feature is the most convenient. So with the power trim you can just scribble with your mouse, with the left mouse button held, and whatever lines it crosses it'll trim away. Okay, so that's that trimmed away. I'll close out of the trim tool. I'm just going to delete that diameter 30 dimension and put it in again as a radius dimension. So right mouse button and up. I'll just redimension this one now as a radius 15. Okay. So my sketch is fully defined, so with a combination of dimensions, but importantly as well this vertical relation between the midpoint and the center of that circle there. So once you're fully defined you can close out of that sketch, and I'm going to take that sketch and extrude it in two separate features. So one feature I'm going to create this 8mm thick web sticking up here, and then the 30mm long base sticking out of this. So I want to take sketch 1 and go to features and create an extruded feature, and it's going to extrude it out in this direction, out in the X direction from the right plane. And it's going to, because there's multiple areas in this, I have to select what contours I'm going to use. So I might do one for the 30mm here, and then I'll do a separate feature for the 8mm thick one. So I'm going to extrude this contour out in that direction by 30mm, and you can click and drag the arrows, or you can type in your 30mm here. Okay, and I'm going to use that sketch again to do another extrusion, and this time select this contour here, and I want to extrude that out by 8mm, or again just type in your 8mm here. If you want to go back in and change what you've done in a feature, by the way, you can right click and go edit feature. I just wanted to point out this little option here, the merge result checkbox here. So I have two separate features that are part of the same body, and as long as this merge result checkbox is on, these two parts, or these two features rather, when they're extruded, are merged together to form a single part or a single body. Okay, so we have the bulk of the work done here. What we need to do now is create two holes, and then lastly I'll add in the fillets. So I want to draw the two holes on this surface here, and again, as previously, I could use the extruded cut feature, but I'm going to use the hole wizard. The holes themselves are just plain diameter 8 through holes, but if you wanted to do any kind of countersink or threaded holes or counter bores or even a reamed hole, you would need to use the hole wizard. So it's probably good practice just to get used to using the hole wizard. So I'm going to use the hole wizard and select the type of hole that I want. Is just a plain hole. It's ISO standard drill sizes, diameter 8, but for example you might want dowel holes, which would be a finer dimensional tolerance, or you could have a screw clearance for an M8, which would be maybe an 8.5 or something like that, or you could have a tap drill for an M8, which would be 6.3 or something like that. I'm not entirely sure. So for just a plain hole, we want drill sizes for a diameter 8, and the end condition will be through all, so we want it to go all the way through rather than being a blind hole, for example. Okay, and there aren't any countersinks necessary in this case. So the position of the holes then, we want to select a plane, so I'm going to select this plane here, and place 2 holes somewhere on that surface. I'm just going to go mouse button and normal 2, spacebar and normal 2, and to find the position of these holes then I'm going to do a center to center dimension of 40 millimeters, and to make them symmetrical then I'm going to create a center line here. I think it's probably the appropriate way to do this. So I'm going to create a center line from midpoint to midpoint and make these 2 holes symmetrical about that center line. And lastly then we just need to define the position in the X direction here. So smart dimension from this back surface to the center, 20 millimeters. Okay, and that now is fully defined, so we can close out with that sketch and it'll generate the holes. Last thing I need to do now is just place these fillet radii. So I'm going to use the fillet tool. The items to fillet will be this corner and this corner with a radius 10. Now that isn't specified, it's not spelled out in the drawing, but it's a radius 10. Okay, and that is the completed part. And again, we'll just check. It should be modeled in such a way that if you change any of these dimensions, it doesn't affect the overall. It doesn't change the design intent. This will stay symmetrical and so on. So we'll change that to 80 and rebuild it just to see what happens. If we change it to 80, you can see the part remains symmetrical. Everything should be dimensioned then. Everything should be dimensioned to suit the overall assembly. Okay, so just undo that. Okay, so that is the finished bracket part. Save that into the same folder as the previous parts, and I'm going to finish up the video at that. Okay, thanks for watching.